Hi, my name's Julian and I'm talking about HiGHS, which is high-performance open-source software for linear optimization. HiGHS isn't a company, but an academic team, and the name derives from its initial members. There's me, my senior PhD student, Yvette Galabova, a former PhD student, Chi Huang Fu, and another current PhD student of mine, Michael Feldmeyer. HiGHS has solvers for linear programming. There is Chi's dual simplex solver that I'm continuing to enhance. It has high-performance serial components to exploit sparsity and parallel techniques for use on multi-core architectures. HiGHS also contains Lucas Shork's interior point solver. This is based on an iterative linear solver and obtains very accurate solutions. There is a crossover to obtain a basic solution. We have also developed a prototype MIP solver for one of our customers. HiGHS began as Chi's dual simplex solver that just solved an LP from an MPS file. We've since added features so that LPs can be loaded directly and problem data can be added, deleted and modified. Yvette has added pre-solve and I've added a triangular crash. There are interfaces allowing HiGHS to be called from code written in languages other than its native C++. There are interfaces for some major applications, and we plan to write interfaces for other applications and are open to suggestions. Access to HiGHS is straightforward. It's available from GitHub via its own repository and CoinOR as open source under the very permissive MIT license. One aim of developing HiGHS is to provide a successor to CLP. HiGHS requires no third-party code. It runs under the Linux, Windows and Mac operating systems, and to build it requires CMake 3.15. The parallel code currently uses OpenMP, but we expect to move to the native C++ thread support library. Web-based documentation for HiGHS is available. The performance of HiGHS can be assessed from Hans Mittelmann's simplex benchmarks for 6 commercial and 5 open source solvers. The performance of HiGHS lags well behind the best commercial solvers, but it's second to CLP of the open source solvers. However, unlike CLP, GLOP, and Zoplex, HiGHS is under active development and its performance is improving. If we're aiming to be the successor to CLP, why is the relative performance of HiGHS so bad? Not all of the features of HiGHS are exploited in its default state. Also, CLP has a better pre-solve, a special crash that's very valuable for some of Mittelmann's problems. It also has a primal simplex solver that it chooses to use on many of Mittelmann's problems, as well as a sprint or sifting variant that's valuable on problems with many more columns than rows. The superior speed of HiGHS relative to Zoplex motivated the writing of an interface to skip. A prototype interface has been completed recently, although it lacks some features present in the Zoplex interface, notably the construction of primal arrays for unbounded LPs and a Farkash proof for infeasibility. It's also not yet fully efficient when hot starting nodes. However, it passes 94% of the skip unit tests, despite some alarming warning messages. Initial results on a relatively easy subset of 95 problems from MIPLib 2017 are encouraging. Skip with HiGHS solves a good proportion of them, although there are some failures to be investigated. When both solvers are successful, skip-Zoplex is meaningfully faster on 41 problems and HiGHS on 7. Overall, taking into consideration the penalty for not solving problems, skip-Zoplex is currently faster by a factor of 2.3. Looking to the future, for LPs, HiGHS is improving the pre-solve, and I'll add a primal simplex solver and sifting, as well as improve the general simplex performance. HiGHS has studied the idiot crash from CLP, and this will be added once the necessary crossover has been written. HiGHS is also looking to improve the idiot crash. In QP, Michael Feldmeyer has written a prototype active set solver that will be used for research and, ultimately, find its way into HiGHS. We have plans to develop a successor to the popular CoinOR MIP solver, CBC, and will write further interfaces to applications. So, in summary, HiGHS is a rapidly evolving software system for linear optimization. It has a wide and growing range of interfaces. It's available for research and consultancy via a permissive open source license and requires no third-party code. Here is a reminder of the link to its documentation and references to the associated academic publications.